Hello and welcome to NAMTalks, the NAMTech podcast series. Today we have a distinguished guest with us from MIT, Professor John Liu. Dr. Liu is a principal investigator of the MIT Learning, Engineering and Practice Group that works on applying design principles to solve STEM skills-related challenges for the future workforce. Dr. Liu leads the education and the workforce development initiatives at MIT. It's called the Manufacturing at MIT. He holds a BS in Applied Physics from Caltech and a PhD in Mechanical Engineering from MIT. John, welcome to India and NAMTech.
Thank you so much for having me.
Let me begin by asking you, what is it that excites you about manufacturing?
Wow, so much, honestly. Manufacturing is about the stuff of society, really. One thing that I ask my students all the time is, think about the room that you're in and remove everything that wasn't manufactured. What do you have? And, Tim Minshall, who is the head of IFM, he has a famous quote that says, unless you are floating naked in space right now, you are at this moment, and I think our readership as well, you are at this moment in contact with multiple objects that are manufactured. So manufacturing touches the closest parts of our lives, but it also is what drives economies as well. I mean, you look at the playbook of whole countries like South Korea or Taiwan, many of them entered into the first world status because they really doubled down on manufacturing. And so you're seeing from the individual lives all the way to whole national economies, manufacturing's at the core, I believe.
We see these two terms, manufacturing and innovation, sometimes used together, sometimes not together.
Oh, yeah.
What's your view? Is it that manufacturing innovation can be decoupled?
That's a great question. And actually, it's something that I think there's probably even more conversations these days as, the public and countries think about, hey, should we bring back manufacturing? But that was a question that was asked 2-3 decades ago in the US. Many people called it the Apple model, innovate here in the US, product design, and then offshore the manufacturing to other countries in Asia or around the world. And, it turns out that Apple also sent their engineers to the factories in Asia in order to make sure that that link was prepared. And so we really were very interested, MIT was very interested in answering this question because it had very large ramifications for the US. And even the chief economist, Larry Summers at the time, at the late 2000s, said, there's no reason why manufacturing really needs to be in the US. It can be like agriculture, save it for the few, and we'll focus on product innovation. So MIT really dug into this in the early 2010s. It's a study called The Production and the Innovation Economy. It was led by what now is the Institute professor, Suzanne Berger. She led an MIT-wide and really global-wide study on what is the relationship between research, innovation, and also manufacturing. And it really turns out that these are intricately linked, that you cannot have manufacturing without innovation. And you cannot have innovation without manufacturing. One of the key examples that I showed in class, even just yesterday, is Max Unibody. Right? We all really appreciate this really elegant and single piece body that is so light and so stiff. That only occurred because Apple could nail the manufacturing process. And so here we're seeing a marriage between product innovation and process innovation, which is not something we talk about as often in this world. So the answer, at least from MIT, is yes, they go hand in hand.
That brings me to a larger geopolitical question about manufacturing. Since you say that manufacturing innovation cannot be decoupled, it means a lot to the way the manufacturing supply chains work these days.
Yes.
And India is a new entrant in this space. And we also have great aspirations to be a manufacturing destination.
Absolutely.
What do you think? What works for India's favor? What works in India's favor? And what do you think are the major challenges?
That's a very good question, which I know you're dedicated to answer as well. I think India has bright careers, right, and bright opportunities. And so when you ask, what's the opportunity for India, as, firms and global, multinational companies start to invest more and more into manufacturing, as semiconductors come in and automotive expands and steel production and so many other areas, right? It's an opportunity for India to learn this beautiful dance between innovation and manufacturing, because you have the resources and the government backing and the industry enthusiasm to create a whole ecosystem from that. Now, obviously there's challenges, but I think something that excites me about NAMTECH is this real commitment to solving the talent challenge.
Thank you, John. My next question is related to the big aspiration India has to be a global manufacturing destination.
Right.
When you see from a US perspective, what do you think are the things which are working in India's favor, and what do you see are the major challenges India is facing?
Yeah, one of the things that comes to mind is news that just broke, I believe, last week. Financial Times was reporting that Apple is now looking to shift all of their manufacturing operations from China to India. And, when I saw that, I remember I immediately posted to my colleagues, like, this is massive news. Not just, for us who observe manufacturing, but for India as a whole, for NAMTECH as well. And so the question, of course, is, how do we best take advantage of this opportunity? There's some challenges in that, of course. As you're trying to scale up production in India, and not just Applied Materials, right? Apple, you have Applied Materials, and all of these other countries wanting to come in and invest and set up factories. Well, who's going to work in those factories? Who's going to fill those jobs? And I think that's a major question that we have to really critically think about. And so the opportunity here is really to think through, what are scalable, high quality models of education that can get, our folks on the ground to become quality technicians and technologists and engineers, and how do we, help connect to families and young people to see, hey, there is, wonderful jobs in manufacturing across the country.
I think you're well put it, it is the young people of this country who could, if trained, educated well, could actually be able to realize this opportunity which we are speaking of.
I think it's a very exciting opportunity.
Very right. The other dimension is, of course, the maturity of Indian companies when it comes to technology adoption. I think many of our companies are still in, say, an industry 2.0, 3.0 phases, not yet there. But I just wanted to bring it here from your perspective. Where do you see, what do you see are the major frontier areas in manufacturing, or which are the most emerging technologies in manufacturing that is, or the ones that are changing the face of manufacturing? Which are the ones you're looking at?
Sure. Well, one technology I think everyone is talking about is artificial intelligence, of course, right? So I'd be remiss to talk about that. I will talk about that, and I'll talk about a couple others that maybe aren't talked about as much. But I think we're seeing right now a kind of an explosion, right, of applications of AI, not just LLMs and Gen AI, but a lot of other particular applications. And I think, you're seeing a lot of use cases these days, right, from AI's ability to affect design, right? So being able to map across the design space, to be able to recommend to design engineers.
It brings me to one of my favorite questions, about MIT. MIT and technology are synonymous, and to us in India, MIT is the mecca of engineering, mecca of manufacturing.
Wow.
I've been in MIT. Last year I was in MIT, and I saw one of these programs, one of these courses, 2.008.
Yes.
Absolutely fascinated by it,
Wow.
20 years in running, one of the most popular courses on campus. Tell us something about it and how it's so relevant even today.
Wow. Yeah. So 2008, by phrase or words, we call it Design and Manufacturing 2. It's actually a core part of the mechanical engineering curriculum for undergrads at MIT. But really, colloquially, the students call it the yo-yo course.
Yeah.
That's what we usually call it, at least the university students. Why? Because there's a project that runs through the entire term where students will start to ideate what kind of yo-yo they want to create, and then carry it all the way to not just one prototype, but you could say small-scale production. And that's really unique, and it ends up kind of forcing the conversation all the way in the beginning about what the relationship is between design and manufacturing. So often in engineering curriculum, you'll see, not just in mechanical engineering, but other types of engineering as well, that we teach people how to apply design principles and our understanding of physics so that we get to the prototype, the one prototype that works. But it turns out, in the industry, if you want to make money, you need to be able to create products at scale to get to profitability, right? And that then is a whole other set of knowledge and competencies and skills that really take you all the way to the beginning, early stages of design. We call that design for manufacturing. And there's really not that many courses out there that cover this set of knowledge and competencies. And so in 2008, in the yo-yo course, that's what we do, right? And so then by the time, yes, they start with sketches and CAD, but then we get to CAM and large, you could say production scale equipment like injection molding or thermoforming, such that by the end of the term, each team will have produced 50 to 200 yo-yos of the same design. And at that point then, it doesn't make sense to sand, something to make it fit, right? I mean, then you just run out of time. And so then you have to be able to apply these, what we call DFM, design for manufacturability principles.
Yeah, I recollect in the MIT campus itself, a whole lot of yo-yos, on the notice board. All the students had made them.
Yeah, it's a big exhibit.
Very good.
Yeah, and then you get to see the creativity of the students.
Very
right?
right.
Like they're interested in the jungle, or they're interested in, they love chocolate, or they're scuba diving or something. It all shows up in this real product that you can bring down and bring up.
The other interesting thing is 20 years, and I also understand there's a third generation of teachers teaching these courses.
Right.
So how has the course itself evolved over the last 20 years?
Sure. So about 20 years ago, a faculty, Professor Chun, was the one who took the manufacturing course, which was still pretty theoretical at the time, and then integrated the capstone yo-yo project, right? That really is kind of, you could say, the integrative theme in the past, across the 14 weeks or so of the course. And then roughly about 10 years ago, Professor John Hart, who's visited the NAMTECH campus as well, a close colleague of ours, what he came and did was he created digital resources, videos, and other types of interactivity so that students could watch the videos at home, right? And then when you come in, we're doing activities together. We call them challenges, right? And so that was something that we call the flipped classroom, right? So now your lecture is homework, and then your homework is done during lecture session. And then now we're really thinking through a couple things. Like one is, actually we just recently started to implement technical interviews, oral exams. Why? Because that's actually how engineers often get hired.
True.
They have to be able to articulate, analyze in real time, and then articulate, their thought process. And people are evaluated at the highest stakes with this. And so that's what we've started to implement this past term. That was led by my colleague, Professor Keith Becker. And then another piece that, I'm very interested in is how do we start to bring in these digital technologies that I talked about, so that our graduates are well aware and, start to become fluent in applying these technologies into manufacturing. So whether that's the relationship between AI and manufacturing or, applications or, one area of research in my group is extended reality, right? AR, VR, right? And that really goes back to, potential interactions and collaborations with machines or humans making sense of their environment if, something like AR is able to help them analyze data in the moment and make better decisions. So I think there's a lot of excitement towards the future of the yo-yo course.
Yeah. The other thing about MIT, and which at NAMTECH we are also trying to do, we are also trying to work with a larger ecosystem.
Oh, yes.
The equivalents are community colleges. In the US is the ITIs in India.
Sure,
it's the Industrial Training Institutes.
Sure.
NAMTECH is working with some of these institutions and seeing how we can support them through outreach initiatives.
Yeah, it's fantastic.
I also understand MIT works a lot with the community colleges. Could you throw some light on what are the various initiatives you're doing there?
Yeah, thank you for asking, Arun. So, one of the projects I think that I'm most proud of is this program that we call the Technologists program. And very briefly, this stemmed out of many conversations with companies who said, hey, John, I wish engineers had hands-on skills, and I wish technicians had analytical skills. And I started to wonder, hey, are we just maybe asking the wrong question? Maybe there's a new worker class someone who combines the skills of a technician and engineer, but is still on the factory floor where equipment and maintenance, these things are still important, but then to help with productivity and optimization and technology adoption. And so this new worker class that we're proposing is now, if things go as planned, we're planning on launching a program in the fall of this year. So the past 2 years, we've been working on mapping the industry. We've been working on creating the content for the technologists program. But then we'll be launching in 6 sites in New England, Massachusetts, Rhode Island, Connecticut, working with institutions like community colleges.
Okay.
And I think it's very important, and I think this is one of the things I really appreciate about NAMTech, is there's like a holistic view on the issues, right? And what does it take to really impact a country at scale? I see that in NAMTech as well, and it's fantastic.
Yeah, I'd jovially remark here, sometimes that we have the blue collar workforce,
right?
And we have, say, the white collar.
Yeah.
Maybe we are getting a sky blue collar,
yeah,
a light blue collar kind
Why
of.
separate? Yeah, exactly. Why separate? So,
spectrum,
so if you have a bridge, right, and that's the premise. This is something I'd like to answer in the next 5 to 10 years. If you have a bridge role, does that also? I mean, that's in operations, right? A role question. Does it also address a career question? Which is, could you have a technician, the same person, right, go from a technician worker class, get trained and do very well, then get educated, become a technologist, do very well here, and then become an engineer. Different worker classes, but could it be the same person?
Yeah.
Right? And now you're linking to what often is very disparate worker classes, different wages, different, kind of ladders together. That would be, I think, a very, very compelling solution.
And I think for India, it's very relevant, because we have a huge workforce at the bottom of the pyramid, which is the technician workforce.
Absolutely.
With no great career opportunities.
Absolutely.
So such programs could actually help them to grow in careers and also have fulfilling careers. Otherwise, it's like a cul-de-sac for them.
That's right. That's right.
And I have also seen, and as part of my MIT visit, you showed me some of those digital technologies you're using. For one of the things which we keep saying is that manufacturing cannot be on how much of online manufacturing could go, manufacturing education could go. Any research happening in the US at MIT which you think is this whole idea of blending online and classroom based, what are the great new trends there? Anything you would
Right. I'm glad you asked. So about 5 years ago, I worked with many of the manufacturing faculty at MIT actually to create this new program online we call the MicroMasters. So that one is essentially taking the first term of our Masters in Engineering of Advanced Manufacturing Design program. That's what normally is a full school year of residential learning. We took the first term, we created an online program for it, and we thought, hey, would this be a useful thing for professional engineers, right, around the globe? I mean, if you're already working, maybe it's a little hard, to take off work and then you go over. And so we created this program about 5 years ago. And at this point, I'm very happy to say it's reached over 160,000 unique enrollments in around over 150, unique countries, right? And so we've seen that this content that MIT has been distilling for decades, it's very relevant for those in, the professional fields. And so that obviously is, hopefully something that NAMTech can also, work through or benefit from. And then, I mentioned before that one of the other aspects that we work on is AR VR, right? And that also is a very exciting area because, for example, what happens if you really want to get up to speed on something really quickly? I mean, do you always need to be sent to a school to pick up those skills? Or maybe I pick up a headset and I download an APK and I can learn in the convenience of my job site or my office or my dorm room, right? And so there's a sense in which we might be able to distribute and scale out the learning of skills much faster once we start to develop AR, VR technologies as well.
Good. Thanks, John, on this. Final question. What would be your advice, for today's engineering students, in terms of the career opportunities, the potential to be a very good in the manufacturing area? What are the opportunities? What could they aspire to be? Your own views on that.
Yeah, absolutely. I mean, one thing I think is to kind of lift your eyes to a longer term trajectory
Very
You know, I've heard that some engineering students in India, you know, maybe they have a little bit of hard time finding a job and then they hop over to business, you know,
Very
and get an MBA. And maybe that's a common issue. But I think, you know, if you continue to really be serious about looking for opportunities, right, find employers, be proactive, I think, in finding, hey, where are the industries headed? We talked about some today, semiconductor, materials, advanced manufacturing. There's millions of jobs coming in the next decade. And, you know, if you're an engineering student, to be looking at where those industries are going, what regions have opportunities. I think another very often undervalued piece of advice that I like to give to my students is, if you're interested in career, don't just read about it from the internet. Go find a professional in the field and interview them. Go talk to them. You know, how did you get there? What helped you prepare? What did you wish you had to get here? You know, what do you like about your job? What do you not like about your job? A lot of those things are not really available on the World Wide Web, and yet they're so important in helping us decide what careers really make sense for us and not. And so that's another thing, you know, connect with people who are actually in the field so that you get a much more realistic picture of what the job looks like.
John, it's been a pleasure talking to you as usual. I mean, one can sense the passion for manufacturing when someone interacts with you. You spoke about a range of issues. You started with, what is manufacturing and the coupling of manufacturing and innovation. You jumped onto the big picture, spoke about the frontier areas of technology. You spoke about MIT, you know, the way MIT is approaching the new age manufacturing. And finally, thanks for the loaded advice for our students. You know, it helps, just surely helps. So as usual, it's been a pleasure interacting with you. Thank you
so much for having me, Arun.
I had fun interacting with John. I'm sure you also enjoyed this conversation. Lot of insights, lot of learnings. You know, this is the first of the many podcasts we are planning under the NAMTalks series. Thank you very much. See you in the next one.